Okay, so we're going to increase the level of difficulty, but it's really not. Numbers are numbers. But sometimes when we write with decimals or fractions, we try to overthink. So similarly, here, I'm going to build the equation, and then I'm going to tear it down to solve for x. So my first step here, to change x, so here's my equation that I'm considering, and I'm going to build the expression on the left-hand side. To change x into 0.4x, I'm going to multiply by 0.4. Now that I have 0.4x, I need to create 0.4x plus 0.8. So now I'm going to add 0.8. And remember that this is equality. And that's my equation. Now that I have 1.2, well, I'm going to work backwards just like I before, and I need to do the inverse of this operation, and the inverse of adding 0.4 is 0.8. The inverse of adding 0.8 is subtract 0.8. And what we have here is 1.2 subtract 0.8 would give me 0.4. Now that I have 0.4, now what did I do over here? Well, I multiplied by 0.4. So in the same step, to work backwards, I need to subtract by, the inverse of multiplying is division. Almost got confused there. So if you take 0.4 and you divide it by 0.4, the answer is 1. So really, am I expecting anybody to build up the equation like this and tear it down? Not particularly, but let's do it algebraically. Notice that the goal is to isolate x. So here, perhaps let's plan this out. If I isolate 0.4x, well then, I know what to do. Let's look at the algebra here. What I'm going to do is I'm going to isolate x. But before I do that, I'm going to isolate 0.4x. In other words, get rid of it. Unfortunately, we have something getting in our way. We need to figure out how to undo adding 0.8. So I have 0.4x plus 0.8 is equal to 1.2. Now, if you notice, I just copied the line above. My goal is to undo adding 0.8. So I'm going to subtract 0.8 on both sides. Now, if you notice, I'm showing my thoughts. I'm subtracting 0.8 to both sides, and what we have here is 0.8 minus 0.8 is 0.4x. And this is equal to 1.2 minus 0.8 is 0.4. So I have 0.4x is equal to 0.4. I know what to do here. Now 0.4 is just like any other number like 2. So 0.4 times x, I need to undo multiplying by 0.4. So I'm going to divide both sides by 0.4. And if you notice, I'm just recopying the above step and divide it by 0.4. If you want, on the left-hand side, we have a factor of 0.4, which I can cross out, which just leaves me with x. 0.4 divided by 0.4, we know as 1. So I hope you're getting comfortable with the algebraic ideas. So it is, I need to isolate for x, and then you do everything in your power to do it. Now, let's look over here. 3.1x minus 7.1 is equal to 1.2. Now we're going to solve with the aid of a calculator. So I'm just going to highlight some facts. Maybe I'm going to solve for x, but why don't I solve for 3.1x first? So I'm just going to recopy out my equation and I'd identify the thing that is causing me trouble. At the moment, wouldn't it be nice if I got rid of this minus or negative 7.1? So I'm going to, what's the undoing of subtracting 7.1? Well, it's adding 7.1 to both sides. So there it is, different color. Now what we see is what I've just underlined in red. Subtracting 7.1 and adding 7.1, they undo each other. In other words, they add to 0 as well. So I have 3.1x is equal to now 2.1 plus 1.2 plus 7.1 is 8.3, I believe. All right, my calculator is ready to go. So now what I would like to do is I would like to isolate for x. But what's going on to x? Well, x is being multiplied by 3.1. So 3.1 is just a number like any other number that we've dealt with. So what I'm going to do is I'm going to do the opposite of multiplying by 3.1. Sorry, did I say opposite? See, it creeps in. The inverse. And that is dividing by 3.1. And the answer that I get is 2.6774. Now, I'm going to round to 3 decimal places here. So I'm just going to leave it as x is equal to 2.677. Hopefully, let's see, is this the last question? Oh no, one more question. 12% of a number is 24. Determine the number. 12% of a number is 24. Word problems. Did you know the word is in math is often an equals? So I'm just going to write 12% of a number is 24. See what I did there? Instead of is, I wrote equals. All right. Well, what's this number? How do I go further? Well, we introduce a variable. So over here, I'm just going to say, let A represent the number. So right now, we can say 12% of A is equal to 24. So how do we find 12% of A? Well, we change 12% into a decimal. We multiply it by A. In other words, remember 12%, to change a percent into a decimal, you either divide it by 100 or you move your decimal place 2 to the left. 0.12 times A is 0.12A is equal to 24. So again, I'm just going to say I have this expression 0.12A or 0.12, and by the way, it's implied that it's multiplying these two things together, and it's easier once I do that because I can just rewrite this as 0.12A is equal to 24, and now I'm just going to divide both sides by. So A is equal to, I didn't, 200. Hey, that makes sense, because 12% of 100 is 12. So 12% of 200 is 24. And there we